Hey guys. All right, guys. The iPad's just not happening right now, so we're going to be on this one here. And so I will kind of walk us through assignment number 6. So we're working on inverse and radicals still. So we have 1 through 3. So numbers 1 through 3. 1 through 3. These are operations with radicals. Okay, so the number one thing is that you got to remember. Oops, let's rewrite this. Number one is in radicals, like terms are the same roots. In other words, you can only add the square root of x plus the square root of x, which is equal to 2 square roots of x. Because there's that imaginary 1 here and that imaginary 1 there. How many square roots of x do I have? I have 2. So you can only combine when the roots are exactly the same. So if I have the square root of 2 plus the square root of 5, that equals the square root of 2 plus the square root of 5. There is no difference because these are not the same. Okay, so the square root of 2 plus the square root of 5 does not equal the square root of 7. So that does not work. So this is no good. All right. So as we tackle this stuff, that means you have to simplify things. So if we take, let's say, the square root of 12, let's say the square root of 12 plus the square root of 2 plus 7 square roots of 2. So if we look at this and we look at it a little differently, I have a 2. I have a square root of 2. So these two are combined, are like each other. But this one here is not like the other two. So what do I need to do? I need to simplify root 12. And how do I simplify root 12? Well, we're going to break it down into two pieces. 4 times the square root of 3. Okay? So let's see what we come up with. 4 times the square root of 3. So, I'm sorry, not square root of 3. Let me Control Z. 3. So then let's rewrite this one, which is the square root of 4 times the square root of 3 plus the square root of 2 plus 7 square roots of 2. So all I did was I broke this down into two numbers because I know that the square root of 4 is 2. So I have 2 square roots of 3 plus 1 square root of 2 plus 7 square roots of 2. Well, if I look at this, and I'll change my color here, these two are the exact same root. So that means that's 1 plus 7. So that means that is 8 square roots of 2. This one is not the same. So this one is not the same. So it stays as itself, 2 root 3 plus 8 root 2. And we have our answer here. So the main concept you need to put in your notes is you need to simplify radicals and combine like terms. Okay? All right. So, I'm going to move some things around on my desk because they're getting in the way here. All right. So that's 1 through 3. Let's work with solving more radical equations. So now we're going to solve more radical equations. Oops, let's move it that way. It won't let me go move that any higher. So we're going to do, this is numbers 4 through 6. And this is solving radical equations. So let's kind of look at something that looks like this. Say x minus 1 equals 4x plus 2. See, something looks like that. All right. So if we look at this, we have two radicals here, and I need to get rid of the radicals. So it's just like before. If I want to get rid of a radical, I multiply it by its inverse. So if I'm going to take this piece here, I am just going to multiply it by its inverse. And if I square it, I get x minus 1. And if I square this, I get 4x plus 2. Okay? So then I just solve from there. I don't care how you work this out. I'm going to move I'm going to subtract 2 from both sides, and then I'm going to subtract x from both sides. And so what that gives me is negative 3 equals 3x, and that means x equals negative 1. So my answer is negative 1. Okay? All right? So, which doesn't make any sense, because if I plug it back in, well, it actually does make sense. Makes imaginary sense. If I plug it back in, I get negative 1 minus 2 equals negative 4 plus 2, which gives me the square root of negative 2 equals the square root of negative 2. So even though I get a negative, this is equal. So that statement up here is true. All right, so that's one way to handle square roots. So when you have a square root on both sides, we're going to go ahead and we're going to simplify it. So now let's tackle the one that usually messes people up. So let's take the square root of x minus 1, and we're going to set that equal to 2x plus 1. Okay? So there you go, 2x plus 1. All right. So this looks a little different. Number one, I have a square root, and then I have this 1 attached to it, and then I have a square root on this side. So with these particular problems, you're going to do a little bit more work than normal. So what I want to do is I want to get rid of this square root right here first. We're going to get rid of that one first. So how we do that is we are going to square both sides. We're going to square both sides, which on the right side here, it turns into 2x plus 1. So we're okay with that one. This side here doesn't do that. It's not as easy as it looks, because this becomes an area model problem. So if I move myself over here, I get the square root of x minus 1 times the square root of x minus 1. So this problem here becomes the area model I'm working on over here. So if I put this together, the square root of x times the square root of x is just x. Then I get negative square root of x, and I get negative square root of x, and I get negative 1 times negative 1 is a positive 1. So I just multiplied my columns. So negative 1 times root x is negative x. So I have two negative root x's. So when I rewrite this side, I get x minus 2 root x plus 1. So let's go ahead and kind of manipulate this, because now I'm stuck here, because I have this brand new square root of x I got to get rid of. So what I want to do is I want to work this thing all the way around so I can eliminate some pieces here. So let's subtract 1 from everything. Subtract x from everything. So we're going to subtract x and we're going to subtract 1. And I'm going to get negative 2 root x equals x. So we've got that piece there. All right. So now I'm left with a square here and just an x there. So now at this point, since nothing's really attached, I can square both sides. So if I square both sides, I get negative 2 squared, and I get the square root of x squared, and I get x squared. Yeah, these are a little bit longer. So I get negative 4 square roots of x. Oops, not square roots of x. Let me go backwards here. Negative 4x equals x squared. So now I've got these two pieces here. So this is where our factoring in different pieces come into play. I'm going to take this, I'm going to add 4x to both sides. Now I get x squared plus 4x equals 0. And so since it's set equal to 0, I can factor it. So I am going to factor using a greatest common factor. So x plus 4. And then I'm going to set each one of these equal to 0. So I'm going to set this equal to 0, x equals 0. And I'm going to set this x plus 4 equals 0. And then I'm going to get x equals negative 4 and x equals 0. So my two answers are x equals 0 and x equals negative 4. So we've got a little bit of extra work here. So let's kind of go back through this. Let me go move this down shrink this down just a little bit. There you guys go. So I will write this off to the side. And I'm going to get, I squared both sides. And then I solved for root x. And then I squared both sides, which is right here. And then I set equal to 0, which is right here. And then I factored using the greatest common factor, which I did right here and right here. And then I set each factor to, let me go back here, equal to 0 and solved for x. Okay, so you're going to need to use this as a reference as you go through, especially number 6. So this is going to take you through number 6. All right. So this week when you're working on it and I ask you what do your notes look like, I'm going to expect to see this piece. All right. So the last thing I want to show you guys is for number 11, the last problem. I can't remember what number it is. I think it may be 10. The last problem. The last problem says graph and show slope. What I want you to remember is slope is the change in y over the change in x. So you're given the x's, And now you have to find the y's before you can, solve slope. All right, guys. So hang in there. This is for number 6. We'll talk to you soon.